The general first-order linear differential equation is in the form dy over dx plus p of xy equals q of x. So looking at the differential equation, y prime minus 1 over t times the quantity t minus 1 equals 0. So first we notice that this is a first-order differential equation, but it is not in our general form. So we also notice that instead of x, we have t's, and that's okay. That means that t is going to be our independent variable. So rewriting this in our general form, we have y prime equals 1 over t times the quantity t minus 1. And now to find a general solution, we are going to integrate. So we integrate both sides. So we are going to get y equals the integral of 1 over t times t minus 1 dt. And to solve this integral, we are going to need to use partial fractions. So we have a over t plus b over t minus 1 equals 1 over t times t minus 1. So that means that a times t minus 1 plus b times t equals 1. So a times t minus a plus bt equals 1. So at plus bt equals 0, and negative a equals 1. So that means that a equals negative 1, and a plus b equals 0. So since a equals negative 1, so negative 1 plus b equals 0, so b equals 1. So that means we have y equals the integral of negative 1 over t plus 1 over t minus 1 dt. So that is y equals the integral of negative 1 over t dt plus the integral of 1 over t minus 1 dt, which gives us y equals negative natural log of the absolute value of t plus the natural log of the absolute value of t minus 1 plus our constant c. We could also rewrite this using our properties of logarithms as y equals the natural log of the absolute value of t minus 1 over t plus the constant c. So this is our general solution, and of course we can check the solution by taking the derivative. And then we should get back to, when we take the derivative, we should get back to 1 over t times t minus 1. Let's say we had y prime equals 4y squared. So in this case, we have y's over on this side. So we would have an issue where if we were trying to integrate both sides, we would have y equals the integral of dy, which is equal to the integral of y prime dt, which is equal to the integral of 4y squared dt. So currently, we cannot integrate as it is, and we will need more techniques. So let's say we're told that y prime of t equals 1 minus sine of t, and we're given an initial condition y of pi over 2 is equal to 0. So this is similar to solving our acceleration, velocity, position antiderivative problems. So first we need to find the general solution to the differential equation. So we're going to integrate both sides. So we have the integral of y prime of t dt equals the integral of 1 minus sine of t dt. So that tells us that y equals t plus cosine of t plus a constant c. To find c, we need to use our initial condition. So y equals 0 when t equals pi over 2. So 0 equals pi over 2 plus cosine of pi over 2 plus c. So that means that 0 equals pi over 2 plus 0 plus c. So negative pi over 2 equals c. Plugging that into our general solution, we have y equals t plus cosine of t minus pi over 2. And we could check the solution by taking the derivative. We won't get into the details, but we should note that there is such a thing as the existence and uniqueness theorems. And it says that the solution of a general first order initial value problem, y prime of t equals f of ty, with the initial condition y of t naught equals y naught, exists and is unique in some region that contains the point t naught y naught, provided that f is well behaved.